Okay, question 8. Big question at the end, lots of parts, lots of re-entry points, lots of breaking it down for you. In part A, we've got to find x starting from this equation, so you've got to gradually rearrange, get rid of the e, then get rid of the minus 2, get x in terms of an exact value. That means leave it as in terms of a square root or a log or a pi or a whatever. Okay, and you can bet your bum that you're going to need that answer later. Never mind. Part B is a re-entry point. You don't have to have done A. We've got to use integration by parts. They're nice. They give you the recipe. Integration by parts is in your chapter booklet, but you have to choose a U. You have to choose a V dashed. You have to use late to make sure you choose the right one. Just do all of that stuff and get 4 lovely, jubbly, easy marks for doing a really standard integration by parts. And in part C, okay, another re-entry point completely in dotty 1. Find the exact values of the stationary point. So stationary point means something. It goes back to core 1. You shouldn't need me to tell you what you need to do to this y to find a stationary point. A stationary point is where a particular thing equals a particular value. You don't need me to tell you that, do you? Pause the video and write it down for yourself. Okay, if you really didn't know, then a stationary point is when dy by dx equals 0. So you find the dy by dx of this, and you set it equal to 0, and you find an equation and you solve it properly, and you don't forget that you've done part A, which is bound to be of use later on. Then you've got to determine the nature of the stationary point, which again is core 1 theory, so it's not dy by dx that tells you what kind of stationary point you've got. It's another thing, and you don't want me to tell you what other thing it is, do you? You don't. Look up your chapter 1, your core 1 notes, or think about it. No, you're not still here, are you? Well, okay, it's d2y by dx squared. Okay, whether that's positive or negative tells you whether you've got positive is a positive, you're thinking that, so it's a minimum. Negative, you're thinking that, so it's a maximum. So the sign of d2y by dx squared, for the particular x value you found, we want the coordinates, that's an x and a y, remember. For these particular x value, substituted into d2y by dx squared. Look at whether it's positive or negative and find out what kind of stationary point you've got. Okay. Alright, so far so good, but even if not so good, you've got another re-entry point here, aren't you lucky? We've got a region R, there's the curve, the x-axis and these lines, and we've got a volume of a solid. It's rotated. 2 pi radians means all the way, you don't have to use that 2 pi, you've got to quote your formula for V, it's a volume of revolution. So it's an integral with something here. And at the end it's d something. Well, we're rotating around the x-axis, which is the hint of the version what we have at the end. And we've got something squared here, which you write in full, and then you put in the brackets squared, and you square out the brackets properly. So you square this all out, and you integrate it properly, and hey look, this integral that you did back up here, if that doesn't actually crop up in the integral you've got to do, then I'll be a monkey's uncle, because all the parts lead towards the final answer. So you square out your brackets properly and you integrate 3 terms accurately using your answer to part B, and you put the correct limits on it and you put them in, and it should be 5 of the easiest marks in the world. And all of these marks on this last question, all of them, if you do it systematically, are dead easy, and there are no excuses for not getting a high mark. And I think I've had enough of this question.